Hello friends, this is Priyanka. Today we are going to solve a problem on hydrostatic forces on surfaces. So in this video we are going to solve a problem about inclined plane surface submerged in liquid. So first I will read what is the given problem. A circular plate 3-meter diameter is immersed in water in such a way that its greatest and least depth below the free surface are 4 meter and 1.5 meter respectively. Determine the total pressure on one face of the plate and position of center of pressure. So this was the given question. Now if we observe the question here, from the free surface of water for the circular plate, greatest depth and least depth is given. That means this plate is getting inclined with the free surface of water. Now we will observe here, or we will consider here, this is the circular plate. Now this plane is making an angle of theta with the free surface of water. So how to draw the diagram? So the free surface of water we have to show with this horizontal line. Now here the angle of inclination theta, that is not given, so we have to draw here one approximate inclined line with this horizontal line making an angle theta. Now if here this is the circular plate, or this is the plane of the circular plate making an angle of theta degree, and its greatest depth and least depth from the free surface of water is given. Now if we observe, this is the plane, and if this plane of the circular plate is getting inclined in this way, then here will be the least depth, and here at the bottom there is the greatest depth, because this plate is getting inclined. Now here we have to, if we observe this plate from the front, we can see this in the form of edge. So here this edge B to C, this is the edge for the circular plate, and this is at point C. Here is the least depth from the free surface of water, that is 1.5 meter, and at point B, that is, this is the bottom point, and here is the greatest depth, that is 4 meter. Now we have to draw here for this edge, we will draw here the whole section for this circular plate, that is the view normal to this plane. So when we see this plate in the perpendicular direction, then we can see here this is the whole circular plate. So this is the whole circular plate, and its diameter is given, that is equal to 3 meter. Now we have to plot here the center of gravity point. So we know that at the center there is the center of gravity. So if we observe, here is the horizontal axis and vertical axis passing through the middle point, and here at this point only there is the G, that is the center of gravity point. So we can extend this center of gravity point here, and we can say this point as a G. Now this view, that is the circular plate, we can draw here, that is perpendicular to this inclined line. So all these lines passing through this point C, point G and point B, these are perpendicular lines to this inclined line. So this is the construction as per the given data. Now we will move for this. What is the dimensions that are given about this circular plate? So here the diameter is 3 meter given. So from that we can calculate the area, that is pi by 4 d square, that is equal to 7.0685 meter square. And here the least depth and the greatest depth is given. So what is the least depth? That is this distance DC, which is equal to 1.5 meter, and greatest depth, that is BE, is equal to 4 meter. Now we have to calculate what is the total pressure on one face of the plate. So for that we have the formula for calculation of the total pressure, that is F is equal to rho GA H bar. Now rho means density, so density of water 1000 kg per meter cube, G 9.81 A, area that we have calculated here. Now H bar, so this H bar, that is the distance from the free surface of water to the center of gravity point. Now if we observe this plate, here at the middle point there is the center of gravity, but this plate is getting inclined in this way. So from the free surface of water we have to draw here one perpendicular line passing through the point G. So here I have shown with this red line, that is from this point G to F. F is the point of intersection on this horizontal line. So G to F shows the distance h bar, that is the distance of center of gravity from the free surface of water. So how to calculate this? Now if we observe this distance h bar, if we observe this diagram, here is the angle theta, here the distance DC is there, distance BE is there. Now we have to make here one construction. So what is that construction? That is from this point C, draw a line parallel to this free surface of water, that is the with the horizontal, that is this line is the horizontal. So I have shown here the line with this dot. Now the point of intersection on this FG we will say here I, and point of intersection for this horizontal line on this BE we will say here as a. Now what is this distance h bar? So h bar is which is equal to line FG, which is equal to Fi plus Ig. Now if we observe this diagram, this is the horizontal line and this is also the horizontal line passing through this point C. So this distance Fi, which is equal to distance Cg, which is equal to 1.5 meter. Now we have to find out this distance Ig. So how to find out? Now if we concentrate on this triangle GIC, now here what is the angle? So here is the horizontal line and here angle theta is in between this horizontal line and inclined line, and this is also line AC, that is parallel to horizontal line, and this is the inclined line. So angle in between them is also equal to theta. So these two angles are same. Now if we observe this GIC, then what we can say here, that sin theta is equal to Ig divided by GC. So this Gi we don't know, but sin theta is equal to Ig divided by GC. And what is the distance GC? So if we observe here, point G is the middle point for this circle. So what is the diameter of circle? 3 meters. So 3 by 2, that is 1.5 is the distance GC. So how we can write this Ig? So Ig is equal to GC sin theta. So we will write here, and what is GC? GC is equal to 1.5. So we can write here h bar is equal to 1.5 plus 1.5 sin theta. But still the angle of inclination theta is not given. So again we will move for this triangle ABC. So here is the triangle ABC. Now again here is the angle theta at point C. So how we can write here formula? Sin theta is equal to this AB divided by BC. Now BC, that we know, whole distance BC is equal to 3 meter. Now what about this AB? Now if we observe this line EB, then we can say that AB is equal to EB minus EA. So EB, that is equal to 4 meter, that is given. Now what about EA? So this EA, which is equal to line DC, because here is the from this point C there is the horizontal line, and here point of intersection is A, that is equal to 1.5. So we can write here 4 minus 1.5 divided by 3, which is equal to 0.833. So this is the value of sin theta, and now we can put this value of sin theta in this formula and we can calculate here h bar. So h bar is equal to 2.749 meter. Now we can easily calculate the total pressure, because rho 1000 G, 9.81 area A, that is 7.0685, and what is h bar? That is 2.749. Then what is the value of F? That is 1,90,621 Newton, and this is the answer. Now again we will move for the next, that is the center of pressure H dash. Now we know that where is the location of center of pressure, that is it is below this point G. So here somewhere here there is the point P. So again I will draw here one construction, that is here is the point P, that is the center of pressure. So again we have to extend this. So we have to draw here one perpendicular line to this inclined line, and here I will say this is the point P. Now how to locate the center of pressure? That is, we will show the center of pressure from the free surface of water. The distance is h dash. So I will draw here one vertical line passing through this point P, and this is, we will say here as a h dash. So I will say P PL. I will give here the name as a letter L. So distance PL is equal to h dash. So what is the formula to calculate this? That is Ig sin square theta by A h bar plus h bar. Now what is this Ig? So this Ig, that is the moment of inertia about the axis passing through this center of gravity G. So here the suffix G is used because the moment of inertia we have to take about the axis which is passing through this center of gravity point G. So what is the formula here? So when there is the circular shape, then or circular surface, then the formula to calculate Ig is fixed, that is pi by 64 d raised to 4. So d we already know, so when we put value we will get 3.976 meter raised to 4. Now all the values are known. Ig is known, sin square theta, so we know sin theta. So sin theta, if we know, that is sin theta is equal to 0.833, then we can take here the value of sin square theta and then a h bar plus h bar. So when we calculate this h bar, we will get the answer 2.891 meter. That is the distance L to P, that is equal to h dash, which is equal to 2.891 meter, and this is the answer.